optimist. What I want to do, I've got this thing here. Let me show you what I got up on Canvas. And I want to do this. So the quiz that's happening right now, just to remind everybody, there's a quiz happening. I have to check and make sure there's nobody taking it that's here in the class right now, but it's always exciting. Let me become a student so this looks like what it looks like for you guys. There is a practice paper I put up here. Hold on. I haven't made it active yet. I love everything to do with Canvas. It's fantastic. Sorry, don't look. All right. I might as well and so down here in chapter 5, you should be able to see section 5.3 through 5.6 practice. It actually starts at 5.1 because I have, I've got a quadratic on here. I kind of want to focus on number 2, number 3, and number 5 and 6. So 4 and 1 are from the quiz, basically. They're stuff you should pretty much have a good handle on. You could ask questions about these if you want to. But I want to focus on number 2, because I don't think we've really directly talked about this idea. I think I did show you this at least once before. So let me show you. Can everybody access this on Canvas? Can you guys get this? Let me know if you can't access that. I think everybody should be able to. So just to show you again, it's under Unit 5. Dadgummit, become a student. All right. It's right there at the very bottom of Unit 5, very last thing. Okay, so let me know if for some reason you can't access that. So let's do this. Everybody put this into your graphing utility, be it your graphing calculator or whatever you use to graph things. Put this bad boy, this is pretty yummy right here. Let me just stop being creepy. This is gross, right? This is, it's got some decimals going on. Yes. So let's put that in the old calculator. Let me bring my calculator up. So let me ask you this. If you've got that paper up, what degree is that polynomial? Anybody?
Four.
Yeah, so 4th degree. How many zeros must it have? Fundamental theorem of algebra. How many zeros must a 4th degree polynomial have? Anybody? No? Don't feel bad. It's just the fundamental theorem of algebra. That's all. So if I have an nth degree polynomial, this sounds like a note to take if it doesn't already exist in your notes. If I have an nth degree polynomial, there must be n zeros. Do they all have to be real? No. Are you guys with me?
Can you repeat that real quick?
Yep. So if I have an nth degree polynomial, right? Nth degree. It must have exactly n zeros.
Thank you.
You're welcome. Some of them could be complex. Some of them could be repeated. Right, so here we go. Let me show you this. In the book, it's on page, I don't know what page, to be honest. It's in section 5.5. but I believe I explained this to us much earlier in the semester because it is the fundamental theorem of algebra. So it's one I like to throw at people pretty early. It's a beautiful thing. It's kind of crazy. Okay. So if we come back to this, I have no idea if that works when I do that. Come back to this. Hopefully everybody's got this up here. I think a few more people just came in. So we're looking at this section 5 through 5-6 practice handout that's up on Canvas now. So if you go to Canvas right now, you should find that under Unit 5. Put this in your calculator. So let me do that here, and then I'll switch over to the calculator. Calculator, where are you? There you are. All right, so I'm going to put it. Well, let's see. Do you guys remember how to put this bad boy in your calculator? All right, dadgummit. Let me do this. Bam. So we go hit y equals. All right, let's see if I can do this. Can you guys see the calculator?
Yes.
Yes, okay, good. So you get y equals, oh crap, no, I can't see enough. There we go. All right, I'm trying to do some nifty stuff here. Let's see if this works for me. All right, so if you do y equals x to the 4th, hit over, minus, crappity doodah. Really? You dorcas. Let's see, minus 0.3 x. All right, I'm having a difficult time. Hold on, let me pull this over here. All right, you probably can't see anything, can you? Sorry, it's a rough technology night already. Okay, all right. 3x to the 3rd, hit over, minus 37.9 x squared plus 72.3 x plus, no, Jeff, plus 80.4. Okay, all right. I think I got it all in there. Blah, 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 blah. All right. So now if I hit, let's hit zoom 6, zoom standard. So I get a standard window, and you can see how gross this is. But at least I can see some stuff happening. All right, I'm gonna zoom out a bit. Let's try zoom fit. If I do zoom fit, let's see if this thing does this well. Yeah, okay, that's well enough. All right, let me come back to you. Hold on, let me switch things around here a bit. Sorry, guys. All right. Now, here's one of the coolest things. I don't think I've gotten to use this too much yet. You can't really see how many zeros there are. If you remember, there's actually like at least 2 zeros over here, if you remember before I zoomed out. So what I can do, this is one of the coolest little things. This reminds me of those dumb crime shows where they say enhance. So if I do zoom box, all right, this is one of my favorite things. And yes, I have a favorite Zoom app, a Zoom thing on my calculator. So don't judge. I'm a freaking math teacher. What do you want from me? So I'm going to zoom in on all of my X-intercepts, because that's what this thing wants me to find. So what I do is if I hit zoom box and I hit enter, that is one corner of my box. And then if I scroll down and over, this is the region it will zoom in on. So that seems kind of useful. So if I hit enter now, it's going to zoom in and look at all that. Now, see, I'm still going to have to zoom in over there, but we'll do that in a minute. Now, I don't know. Anybody playing along with me, or you guys all just watching? I don't know. Now, if I do second calc 0, I can find the zeros. So I'm going to do one of these, And once you see how one of them works, you can do more later. So I hit on the left side of the answer, on the right side of the answer, and then right on top of the answer. As close as I can get. And there's the 0. Now, real quick word. I'm kind of happy this happened. An X-intercept should have what Y value?
0.
What Y value does this have?
Something stupid.
All right. It is just a poor little number, right? Can't be very smart. It is almost 0, though. Oh, yeah. So some of you guys, your calculator might, depending on how you zoomed in, and this is a calculator emulator, so it might not be the same as your handheld, but this will happen to you. Do you guys understand what this stupid thing means?
It says the same thing on mine.
Oh, okay. But somebody else, and again, it depends on what you picked for your Zoom. Does somebody know what this means? What's that E mean? Does anyone know? Is that like -9?
The 11th power or something like that?
Times 10 to the -11. It's scientific notation. So it would be move the decimal back 11 times, right? For most humans, that would be 0. You guys with me? So this is really just, this is kind of neat because there is a higher level math course where you actually learn the algorithm that the calculator uses to do what we just asked it to do. And it gets to within a certain tolerance and it stops. Sometimes that tolerance makes it stop before this is exactly 0. I have no idea if any of you understand or interested, but that's why sometimes this is not going to be exactly 0. It's as close as the calculator felt like getting, right? Just to attribute some kind of emotion to it. All right. Now I can see 1, 2 roots. So let me come over here. Let me zoom in over here. I'm going to use zoom box again. Weehaw. Let me see. I can zoom in really close. What? All right. And there's, oh yeah, look at that. I still can't see it. I get to use zoom box again. I'm sorry, guys. I can't stop myself. I really want to be able to see this stuff here. All right. Let's see if I can see it now. Did I go too far over? There we go. Now I can see 1, 2 more. All right. So there's a total of how many real zeros? 4. 4 total. And how many total zeros were there supposed to be? Oh, shoot. Where did I? Oh, crap. I've lost my. Here it is. So how many zeros were there supposed to be? 4. Okay, so they all happen to be real here. So how many complex zeros can it? I should have said can. It doesn't even, none. It can't have any complex zeros because all 4 of them are real. So if I would have just seen 2 real zeros, right? Especially if they, now I gotta be careful. This gets a little complicated because if it bounces or turns, that would be a multiplicity of at least 2, right? But if they went through, then it has 2 real, it must have 2 complex. It's got to have a total of 4. Okay, I'll let that drop. So that's fundamental theorem of algebra. Okay. Now, can you guys take a minute? This will be good review here. Can you just take a minute and figure out everything Descartes' rule tells us about this? See if you remember.
3 sign changes.
Oh, wait, don't say anything. Sorry. Yeah, so there's 3 sign changes. We'll leave it at that. Everybody can see that. Now, everybody just take a minute, figure out everything Descartes' rule says, and then I'll ask here in a minute what you guys got. Can I open this up a different way? What was this called? 5, 3, 3, 5, 6. Okay. Of course, it's not that. All right, Jeff. Is that it? Yeah. Sweet. All right. Let me see. Oh, no. No. You doofus. Let me see. Hold on, guys. I'm trying to get this better for myself. Oh, that's neat. Let me stop sharing. There we go. There we go. Okay. So let me pull this up. Bam. All right. So all right. I need someone to help me with my pile of stuff on this desk. Okay. So we're on this one here. So what does it say about positive real roots? How many possible positive real roots are there?
3 or 1.
Yeah. So you see 3 sign changes, right? There's, oh crap. Oh, you guys are so patient with me. I think some of you guys are muted and everything. I don't know what you could be doing out there. All right. So if I look at the function as it is, it's got 1, 2, 3 sign changes. So Descartes says, oh, somebody's chatting at me. 3 sign changes. I love it. So hopefully everybody understands why. So the possible positive real roots would be 3 or 1. Remind me again why it's goes down by 2. Oh, you did the wrong one. Neat. All right. Why does that go down by 2?
In case some of the zeros are irrational.
No, no. So these are all the reals, which includes rationals. So it could be any real positive root. If it isn't real, it must be fake? No. If it isn't real, it must be
Imaginary.
imaginary or complex. And they come in pairs, remember? Complex answers to real valued functions come in conjugate pairs because of quadratic with a plus or minus. That's why it makes all the sense in the world. I have 3 real roots, or I lose 2 that are complex, or I have 1 positive real root, right? 3 positive or 1 positive. What about negative? What do I have to do to figure out negative real roots?
Change the sign.
Yeah, so I plug a negative x in. And I'm just going to write the signs down. So every odd powered term, sign's going to change, right? Every even powered term, sign's going to stay the same because the even power is going to kill the negative. Is everybody with me on that? I think so. So I'm just going to write the signs. Negative, negative, positive, positive, negative, negative. So all the odd powers change signs. This one went from positive to negative. This one stayed. This one changes. This one stays. I'm sorry, you can't see when I do that. This one changes. This one stays. This one changes. This one stays. This one changes. This one stays. So how many sign changes do we see?
2.
2. I like it. So possible negative real roots is 2 or 0. All right, I love it. You guys with me? So was Descartes a lot of help? No, the answer is no. Descartes was not a lot of help. When is Descartes a lot of help? It's really only a lot of help when it comes out to say no positive or no negative, right? There might be no negative, but there might be two. Shit. So, all right. So I understand when I learned Descartes, I was kind of like, all right, so most of the time it's shit. Thanks. But for the times it helps, it cuts the list in half. So, hey, that kind of lets it stay in the lineup, right? Oh yeah. All right. Can you take a second? Now, this is a little more interesting of a problem than we've looked at in a little while. Can you tell me the list? Oh, all right. Somebody's asking me about the two thing. So remember, there was that whole thing I did. The same end, I like that. Super Saiyan. I'm just saying. You said the odd changes and the even stays the same. Yes, I did. That's right. Are you asking a question about that, or are you just? I'm not sure. So let me address this one thing first. Do you remember that picture I drew, and there was like this, and there were 3 real roots, and if I lift this up, there's 1 real root. What happened to the other 2 roots? There has to be 2 more roots, but they became complex. Okay, just a second, Paul. Somebody else has asked me privately something. You guys all with me? This is just a real quick, remember that picture I drew? I don't know if you guys remember, but if I were to lift this graph up by adding something, vertically shift it, wouldn't it lose 2 of its real roots? It would just have the 1 real root back here. You guys with me? So where'd the other 2 go? They become complex. So that happens in pairs. Now, the more algebraic reasoning is, I will break this bad boy down until I get to a quadratic that I can't do. And that will have, it'll have the plus or minus business. So that's why if there's complex answers, they show up in pairs. So there's 3 real positive roots, or 2 of them are complex. So then there's only 1 real positive root. That's why it changes by 2. Is that cool? All right. And then somebody else is asking me, all right, now listen, guys, all right, I'm going to do this one more time here. Let me see. So let's actually look at the full thing here. All right. Get out of there. So if I put a negative X in, this is what happens. Jeff, you could do it. There you go. What's going to happen with all the even powered things? What's going to happen to the negative? So what's going to happen to all these terms? All 2 of them. What happens here? What do I get when I raise a negative to a even power? What's
Becomes
happening
positive.
out here? Yeah. What's going on with you guys? All right. It turns positive. Thank you. So will this sign change then? Will the sign it had change if this piece becomes positive? No. What's going to happen with these guys, all the negative powers? Or, odd powers, really. Not negative power, but odd powers. What's negative something to the 5th power? Isn't it still negative? Isn't that going to change this guy's sign? Negative cubed is still negative. Isn't that going to change this guy's sign? That's what I mean. So when you do Descartes' rule, the shortcut for looking for negative real roots is all the odd powered term signs change because of this, right? If I have 5 negatives, they're going to pair up. They're going to die, and then you have 1. No, I'm sorry. You're going to pair up, right? Bam, they kill each other. You got the 1 left over. So that's an odd number of things. You got the odd man out. It changes sign because you got that 1 negative left alive. Okay. All right. Is that better? Is that all right? These seemingly complicated ideas are based on very simple things, but it's easy to forget what they're based on. So I understand that. All right, now let's see how much you remember from what we did recently. Can you guys show that 5 is an upper bound? Take a minute. Try to show me. Oh, wait, we haven't done the list yet. All right, sorry. I'm getting off track. First, make the list. I don't know if anybody's done that yet. Make the
did.
complete. Sorry?
I did it.
You got it? Okay, hold on to it.
I also did the 5 thing.
Your list. So try to. Ah, geez, Jeff, what is that? All right. There you go, buddy. So let's make the list of possible rational roots. How do I do that?
You take like the negative 48 and then the 2, and you find their factors and you divide
Good.
them.
And the ratio of those. I love it. And does anyone remember why we do that shit? All right, quick little side note. Now watch. I mean, all right. I'm going to erase this when I'm done with this, but all right, now watch. If I multiply this out, I'll get minus 3x plus 12x is plus 9x. All right. What's the 0 of this guy? Here, I'll do this guy. This guy's negative 6. Whew, I'm tired. Now you guys, what's the 0 of this guy?
3
3.
halves.
3 halves. I love it. It's a fraction, right? Where did the bottom of it come from? From the first number. Where the top of it come from? From this guy, right? Which is, what is this guy a piece of in the end result? The last number. What is this guy a piece of in the end result? The first number. So what's all the possible rational roots would be all the pieces of this guy divided every which way by the pieces of this guy, right? So all the pieces of this guy divided by all the pieces of this guy, because you could see where that 0 came from. It came from this divided by that. That's where they would all come from if they were fractional power zeros, right? Does that make sense? All right, all right. I love you guys. You guys are like, don't make this easy on them. Don't let them know. Okay. Go away, go away, go away. Go away. I need a giant freaking eraser on this thing. All right. Blah, 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 blah. Go away. I can't get lost. Okay. So on the top, all the factors of 48, there's a lot of them. There's 1, 2, 3 goes in, 4 goes in, right? 6 goes in. And then finally, what's really nice is when you turn the corner. 7 doesn't go in, 8 goes with 6. Okay, thank God, I turned the corner. I don't know if you guys understand. So now I just have to think about the pairs that go with what I've already written, right? 16, 24, 48. Okay. When the bottom goes 1, 2. Thank God the first number is just 2, right? So let's see, what do I end up with? So I end up with all these things over 1. Okay, so that's just all of them. 1, so plus or minus 1, 2, 3, 4, 6, 8, 12. This is exciting, Jeff. Thank you. Now, hopefully you guys agree that all the even numbers up top are going to result in no fractions, right? Because I'm going to divide by 2. It's going to be something I already have. What do I get when I divide them by the odd ones, though? So now this is going to be, oh, I left out 1. So I get 1/2 and 3/2, and that's it. Because everything else, when I divide it by 2, it's something I already have. Does everybody get that? Okay. Now, isn't that kind of a long ass list? Shit, yeah, because it's twice as long as it looks because they're all plus or minus. So now take a minute. Let's see if you remember. Don't say anything. Try to show me that 5 is an upper bound, meaning there are no zeros above 5. Let's see if you guys remember how to do that. Let's see if you remember what you can do at the end of that. All right. So can somebody tell me what you're doing? Even if you're drawing a duck or something, just to make it look like you're doing something.
Synthetic division.
Synthetic division. So if I synthetically divide by 5, and I'm not missing any powers here, right? So I don't have to worry about throwing a 0 in the mix. Don't forget about that. If I start doing this, it starts off kind of innocuous. It's all nice. Everything's, oh, it's acting so nice. Keep an eye on me, though, after last night's debacle. I need you guys to double check. So that's just 240. It's still not too horrible. And then here at the end, it's just like, can everybody tell it's not going to work? Everybody tell this is going to be big ass positive. So this is positive. That's all that matters. At the minute you know it's not going to work, it still might be valid to figure out what the sign is, because what does this result, of course, tell me? I kind of gave it away the way I asked this question, but what tells me it's an upper bound? The fact that these are all
Positive.
positive. So I divided by a positive number and the result was all positive. Therefore, 5 is an upper bound. And also 5 itself didn't work, right? 5 itself did not work, obviously. All right, so let's see. What's our list look like now? All right, so this is gonna suck a little bit because we didn't find a, well, let's try to find a lower bound. What do you guys think? How do I tell if there's a lower bound? I divide by what kind of number? Why did you try 5? Oh, I see. Oh, I didn't even remember. I don't know why. That was kind of dumb. So I appreciate that. But if I would have made you try 6, then, you know, it still would have been, it wouldn't have worked either. That's a good point. I guess the point there is, I'm trying to think what past Jeff might have been thinking. It doesn't matter what you do. The result still means it's an upper bound. So it would have been smarter to divide by 4, wouldn't it? But too bad. Nobody said anything. So, sorry, I cut somebody off. If I want to try to find a lower bound, I have to divide by
Negative number.
negative number. So give me an idea. What negative number do you want to divide? Maybe make it one in the list.
-6.
-6? Okay, let's try -6. See if I have enough room for this. I'm gonna have to squeeze it in there. Okay, this will make it. All right, let's see what happens. And what are we looking for in the results? What's got to happen in the results to be a lower bound? It's a little bit weirder.
Alternating signs.
Alternating signs. And it is built on the same idea that Descartes is kind of built on. So it's kind of nifty. So let's see what happens here. Does this work? Is anybody ahead of me here? What is that? I don't trust myself anymore. Is that 102? Is that what that is? I think so. And that, of course, is going to be something. I've heard of that before. I think it's 81, right? 81, and this is going to be negative 486. So this is going to be negative 458, I think. So this is going to be big positive. So this is going to be big positive, and then this is going to be big negative. So this is going to be big negative. Are you guys? The less comfortable you are with that, you've got your freaking calculator there, right? I'm trying to do this in my head. So that's why I put the little plus sign, meaning big ass positive. All that matters now is that I can see that does the sign alternate throughout? Does the sign alternate throughout? Yes.
Yes.
So therefore now, I'm sorry, I'm yelling at you guys. -6 is a lower bound and 5 is an upper bound. So what's my list look like now? 1, 2, 3, 4, and then my, where'd it go? There it is. Then my fractions. That's what my list looks like now. And I eliminated -6, and of course +6 was already eliminated. I don't know, is everybody, +6 was eliminated because that's an upper bound. So 6 won't work, it's above 5. And of course -6 is eliminated because it didn't work. All right, maybe. All right, so let's have a little contest. Can somebody try to see, let's see who can get the remaining zeros the quickest. Or actually, we haven't found any yet, have we?
I have
Let's
two
see
of
if any-
them.
All right, be quiet. If you find all of them, chat it to me. Privately, right? Don't let anybody else see your answers yet. Not yet. I don't know. Maybe I should be working. No, I've been working enough. You guys work. Let's see. Okay. All right. Really, that works? Let me see. 24, 24, 4, 4, 4. Oh yeah, totally. I like it. All right, somebody's got 2. All right, I'm gonna make some room here. So hopefully you guys took notes on what I've done so far. Yeah, maybe so. So I didn't give away too much. I think you're right. I think Past Chef was even a little more evil than I am. That's weird. All right. I'm going to erase this work here with the bounds so I can have some room. I can't let anything survive. Okay. Now you can go too. Go away. It was pre-calculus all along. Okay, come on. All right, somebody's got 1 of the zeros. All right, guys, has anyone gotten, so somebody's gotten 2 things to work that I know of. So let's see. It was. Thank you for getting that. I can't get that out of my brain right now because I just watched a YouTube thing about Easter eggs and stuff like that. Yeah, I agree. There's a third witch. Yeah, exactly. There's a third witch. Maybe. I don't know. All right, so somebody got, let's see. I'm going to erase, let me see, I'm going to write this up here so it's out of my way. Somebody got 4 to work. Did anybody else get 4 to work? If not, then I've just given you an answer. All right, so I'm going to do 4. It doesn't matter what order you get things to work in, right? All right. So 2, 8, 3, 12, -9, -36, -8, -32, 12, 48, 0. Yay! So 4 worked. Does that mean I crossed 4 off my list? If 4 worked, do I cross 4 off my list?
No,
No.
No. Why?
it could be twice.
It could work again. Exactly. I like it. I like it a lot. All right. And somebody else is telling me that 1 works. So I'm just going to build onto this. Right. Essentially, this doesn't exist anymore. This, where we started, it doesn't exist anymore because I've broken it up into x minus 4 times what that means, right? So now I'm just going to keep going. I'm going to keep working with where I am. So let's see what happens with 1. So you could have found these in a different order. Can I talk and think at the same time? Apparently, yes. Okay, good. Ooh, somebody else found a nifty one. Calm down, Jeff. Anybody else found one besides 4 and 1? A lot of people told me those too. Guess what works? It's probably the thing everybody doesn't want to try, which are the fractions. So if you haven't tried yet, try 3/2. Right? The nice thing is this is going to come out even. 2 times 3/2 is 3. So that's 8. Oops. Oh, all right. Wait a minute. Let me make sure I understand this question. Do I have to keep going with division? What happens if you try again from the original set of values? So the minutes, I really want you guys to get this. I'm trying to find all of the roots and get the complete factorization, right? Right here, this work means that I know x minus 4 went in. You guys with me? X minus 4 is a factor. Is everybody cool with that? Because of this. That worked. That's related to x minus 4. So I've already basically divided the original polynomial by x minus 4, and it ended up with these coefficients. Why would I start with the original polynomial again when I've already broken it down into x minus 4? That's done. Other big chunk. Oh, shit. I got to keep working on another big chunk, right? You guys, does that make sense? That's why this stacking idea makes it less writing, right? Hopefully it makes some sense. Somebody else, oh, really? Does that work? Well, let me finish this up here. Let's see. Oh, shit. You guys are chatting at me. I can't handle it. Maybe. I don't know. Maybe. Let's find out. Because remember, there could have been no negative roots, right? It was possible. So let me see. Where am I at? 8 times 3/2 is 12. 8 times 3/2 is 12. Look at that. Yay. Now, all right. So, and what did I get from here? I got, what is this? What root is that? What factor is that related to? This one.
X minus 1.
X minus 1. Now, what factor is this related to?
X minus 3/2.
Sort of.
Is it the 2x minus 3?
Oh, shit. Why is everybody chatting at me? All right. All right. Everybody's giving me the same answer. I love it. Yeah. So I want you to, so something, let me see. How can I do this? If you do, how do I do this with you guys? All right. If I write this down, that does go with this, right? But this goes with half of these. So I'm going to kind of move. Let me see if you guys can handle this. I don't know. So I actually got 1, 4, 4. So I think people are telling me that, oh, let's not do that shit. Hold on. All right, I need room, guys. I'm gonna erase some of my stuff up here. Oh my God, this is crazy. Come on. cooperate. Oh my God. Okay. All right. Somebody's chatting at me. I can't handle it. Can't you refresh? Oh, no. Well, I don't want to lose everything else. That's the thing. All right. So what do I have so far? I got x minus 4. I've got x minus 1. I really want to explain this better. So let me write down x minus 3 halves, because that's pretty much what that directly relates to. And then I have 2. What's this? What's this?
2x squared plus 8x plus 8.
Good. Because the only thing that could have been a fractional piece was 0. I like it. Now, do you see how there's a factor of 2 that I could take out of there and put in here?
Yes.
This would be x minus 4, x minus 1, 2x minus 3. And then this piece, can you factor this piece? So now this is where everybody's chatting at me. There's one more number people got to work. And that was, how do you factor that?
Plus 2. Plus 2.
Okay, I like it. So we actually ended up with the maximal. How many positive zeros did we get?
5.
No.
Oh. 3.
3, because these are going to be related to the 0 of -2, multiplicity 2, right? So I got 3 positive real roots, and I got 2 negative real roots. So in this case, Descartes came out to be the maximal. There were no complex answers. Okay. How's everybody doing out there? Are you guys doing all right? Is that better? Now, we'll tell you this. On the next quiz, you'll have a problem like this, and then the next step after this will be to graph it. Because don't we have multiplicity information? We have zeros, multiplicities. You can find the y-intercept. You got n behavior, right? Yummy. And this is where I would tell you, do all this work and well, I don't know. How would I do that? I'll figure it out. I don't want you to be completely on your own to figure out how to factor that, because if you can't, then you can't do the problem, and that sucks. All right. Any questions on that problem? I mean, there's a lot going on in that problem.
I have a question.
Yes.
So you said if the degree is 5, there should be 5 zeros.
Totally. Yep. And there are.
Then if you get only one real roots of one positive real roots on this, how do you say it? Like if you get only 1 or 0, like in this, there should be like 4 in the imaginary numbers.
Good. If you get one real root, there has to be 4 complex roots.
Okay, thank you.
And a real quick visualization of what that might look like would be, here's the one real root, and then all the other, it's a 5th power. So how many turns will it have at
4.
most? 4. So there's 1 turn, 2 turns, 3 turns, 4 turns. So here's one real root, and all the other roots are imaginary, because if I shifted this down, wouldn't it have 1, 2, 3, 4 more real roots? But since it's not shifted down, those are actually complex roots. What would be the end behavior? Oh, I'm not sure where you would get 15 from. Did you add them all up? So it's the highest degree. The degree of the polynomial is the highest degree I see. Yeah, that's what I would do. In fact, sometimes you could even get, so somebody's asking if you stop at a quadratic. I would definitely stop here, because then you could either factor it or you need quadratic formula. Could you keep going with synthetic? Of course you could. But why? Now it's either factorable or it ain't. So you might as well just try to factor it or do quadratic, right? You could even stop at the third power sometimes if it happens to come out to something factorable, like grouping will work. I don't know if this is making any sense. So how far do you have to go with synthetic? You actually you only have to go as far until what's left over is factorable. If you could see how to factor, you can stop synthetic. Right? Or you can take it all the way down if you love synthetic, and I don't blame you for loving synthetic because it's freaking awesome. Okay. I'm not going to worry about 4. You basically should know that already. And this is the newer stuff. Why did I give no room for this? That makes so much sense, Jeff. I don't know. All right. So let me see. Intercepts has to be simple. So how do I find the x-intercepts for a rational function? What do I look at?
The top.
Top. So when's top 0?
-3.
And what's the multiplicity on that? Oh my God, what word is that, Jeff? Come on, you can do it. Anybody? Yeah, it's 1. Yeah, it's not square or anything. It's multiplicity 1. So it's going to go through its x-intercept. So does that still apply? Of course it does. Even if it's a rational function, I can still look at multiplicities. What's the y-intercept?
-1/4.
Good, -1/4. Now take a minute and figure out the vertical asymptotes and the horizontal asymptote, please. Hold on to your butts. All right, what are you guys doing to figure out the vertical asymptotes?
Making the bottom equal 0.
Yes, vertical asymptotes are created from x's that aren't in the domain. That's why there's a wall there. It's like you can't go here. You're not allowed to be here. So of course, to do this, how do you factor that on the bottom?
+8, -3.
Yeah, that kind of sucks, Chef. Oh well. So vertical asymptotes are at -8 and 3. Horizontal. What situation am I in for the horizontal asymptotes? What are the situations defined by?
The coefficient, or no, not the other thing, exponent.
Denominator
degrees.
is bigger than
Yeah, the bottom degree is more than the top degree. So when x gets big, this thing is going to go to, I'm dividing by bigger, bigger, bigger. So the whole thing is going to go to
0.
0. Does everybody understand that? Anybody not understand that? Anybody care? All right. Man, you guys are really, I guess it's Thursday. Has it been as rough of a week for you as it has been for me? Maybe so. All right, don't worry, guys. We're almost done here. I'm going to do one new thing tonight. This is all review. And then to graph this thing, let me see. Let me give myself some more room. There we go. Look at all this room up here. Wow. So if I'm going to graph this thing, whoa, shit, Jeff. Oh, well, we're just going to go with it. What do I know? Where's everything? Oh, of course, my x-intercepts back here. So let's see, 1, 2, 3, 4. 1, 2, 3, 4. So I have an x-intercept at -3. That's not much information. That kind of sucks. An asymptote at the x-axis. That's how I designate that. I've got, shit. What did I already do wrong? So in order to figure out scale, you do have to consider everything that's in that related to that axis. So I'm going to need an asymptote at -8. So I might as well do this by -2, -4. You guys see that? I got to keep an eye on all my intercepts and all my vertical asymptotes. That tells me what my scale needs to be so I can get there. All right, so there's my -3. There's my vertical asymptote, which my perspective is weird. How do I still make this crooked, even though I'm sitting down? Oh, who knows? And then there's one at 3, right? Pretend like that's a 3. All right, so I don't have much information here at all. Can somebody give me some ideas of values I need to throw into my function?
-6.
Let's see. Yeah, okay, I can handle that. So I'll let you do 3 inputs. So -6 I'll take.
6.
I'm sorry. 4, yeah.
-10.
-10. Okay. I like it. So you definitely need something up here because it could be on this side or that side. Same thing back here. It could be on this side or that side. And I understand why you said -6, and I want to show you why that really isn't necessary, but we'll do it. We'll do it. So when you throw a -6 in, can somebody do that real quick? Why do I not do what I normally do? I don't know. What's that? That's going to be gross. Let's see. 6 over 2. Is that -6 over -18? Is that 1/3? It's got to be up there somewhere. I get 1/3. Is that what you guys get? All right, I'll never know. I'll keep going. Let me see. Then I get 14 over 12. So I get 7/6 for 4, I believe. You guys can correct me if I'm wrong there. And then I get -14 over, oh, this is going to be neat. Let me write this down. -14 over -2 times -13. Okay, hello. So I get -7/13. Why not? I think that's what I get there. You guys doing okay out there? You guys have calculators. I'm not letting myself use a calculator. You can use a freaking calculator. So let me know if I'm kind of wrong on these. So why does this make sense? My y-intercept is going to be, I really want this to make sense. My y-intercept is going to be down here. Am I going to go through or turn here? At the x-intercept, am I going to go through or am I going to turn? We figured it out down here.
Through.
I'm going to go through. So if my y-intercept is here, I know that I've got to start up here and go down like that. So I already knew that this should be up here, and so that kind of confirmed it for me. So what kind of scale do I want to use on my y-axis? My y-intercept is 0, -1/4. All my outputs are like, I only have one output that's more than 1. So I'm going to frickin' use I'm going to use 0.51. Why the shit not? It's up to me. I'm in frickin' pre-calculus. I can make it whatever the hell I want to. As long as it's consistent, right? This is something you guys don't get a lot of practice with, is like scales that aren't whole numbers. I mean, sometimes you want to do that or else everything's squished. All right, so let's see what happens here. F of -6 is 1/3, right? So 1/3 will be roughly right here. on my sideways scale here. F of 4 is 7/6, so it's going to be a little over 1, so it'll be right there. And f of -10 is -7/13. That's just under 0.5. So there, okay. Now, I really hope you guys get this next thing. The walls pretty much do all the work for me. I know it's got to slam up against that wall, slam up against that wall. I'm done, right? This really should be more curving. All right, we'll get that. And then in the middle here, it's got to slam up against that wall. It's got to go through there, and then it's got to, oh shit, where's my y-intercept? That's what I forgot. Let's try that again, Jeff. My y-intercept, I never graphed it. It should be right there. That's going to make that a little bit grosser, but too bad for everybody. It is a -7/13. What did I do? Oh, I put it up there. Good job, Jeff. My bad, guys. Rawr. So it's -7/13, which is just less than -0.5. There we go. So same thing applies. It's got to slam up against that wall, slam up against that wall. Here, it's got a wall. It's got to go through there, there, and there, and then it's got that wall. Now, that's a little bit crazy of a turn, but oh well. And then here, it could have been up here or down there. And of course, now we know it's up here because of this dude. So it has to be up against that wall, and then it's got to eventually get up against that wall. Okay. So the walls come tumbling down. Great, Jeff. The walls break it up into these regions, right? And when you have a horizontal one, then it's really nice. I just have to have one point, and then I know where it lives. I know where it lives, and it's got to slam up against the walls. And if you craft this in the calculator, you can kind of double check and see if it's the right answer or not. Okay. I'm not going to do the other problem right now. Too bad. I need to do something new before I let you out of here. So here's the new thing. Any questions on that, by the way?
How do you know the graph in the middle moves like that?
Oh, well, this I pointed out was definitely not correct. It doesn't have like a kink like that. But other than that, how do you mean? Like, let me see. How else could I graph that? Let's see. So I know it doesn't come down here because it would need an X-intercept. So it's got to start up here, right?
Okay.
So it can hit that point. And I know it's going to go through here, which is good. So it can hit that intercept. So it's got to be against this wall. And then it's got to come over through this point, through that point. Jeff, God, that's gross. All right. Through this point. All right, just deal with it, Jeff. Through that point, it's got to go through this point, make that point big there. And then it's got to come down against this wall. Now, I'll bet you anything it's the curvature through those are more interesting than what I've done. But I'm seeing way too many problems with people are turning in where it does something like this. You'll never see a freaking polynomial do this shit, right? So don't, it's got to be curvy. Curvy. In calculus, you actually can learn exactly what kind of curvature it's supposed to have. We don't know that shit, but I need to see curvature. Don't make these straight lines. You know it's not linear.
So my question is, so if you look at this kind of function, like similar ones, the middle always moves like that?
So there's a lot, how do I say this? What you're asking about is where we can get a lot more interesting. Like if I had a family of functions like this. Right? And you're like, well, what if I change something, or what if I make that negative? What if I make, right?
Yeah.
Now you're talking about how do families of functions interact, and what is it about this function that made it look like this and that would make other functions look like that, right? Like why didn't the middle go like this, right?
Yeah.
That's kind of like the next level of, we haven't even done any of these much yet. So after you've done several of these, you would hope that it would naturally come out to you what seems to be causing that to happen. But we can revisit that after more people have done all this homework. We could try to see a little bit about what would I change here to make the middle go like this instead. Right?
Okay.
Okay. But that's a really good question.
So for now, I should just look for all the intercepts and asymptotes.
Yes, if you do all this, it will happen naturally, but I agree with you. It'd be great if we knew ahead of time that it does do this. Then I would have less work to do, right?
Yeah.
But that's kind of like why I don't want to talk about it yet, because I need you to do all this work so
Yeah.
you can make a connection from that side. And then after that, we can make the connection from the other side.
How do you know if it looks like a parabola in the middle?
Oh, one big clue for that would be if there were no x-intercepts, it would have to look parabolic, right? Yeah, so one thing I could do, Rio, is I could have changed the top so the x-intercept is actually over here or over there. So I could change that 6. So that 6 seems to position this. Anyways, I don't want to talk too much about that. Does that make sense, though? That's one way, Jordan, is if I had no x-intercepts, then it would have to be totally down here or totally up here. Is that cool?
Okay.
Another way is if the top was squared, then this would have been, I would have turned here at this intercept, and then it would have been parabolic one way or the other. I like it. These are beautiful questions. I love it. And you're just trying to make it so I can't do my new thing. No, I'm joking. All right. I'm going to stop sharing. So there is one last section in chapter 5, and there actually is barely anything new in it. There is one really neat new thing in it, and that's what I'm going to talk about right now. In the little bit of time we got left, you guys were dragging at the beginning of class, so just try to stay with me. All right. It's a very friendly board. It wants to say hi. All right. So real quick, what's the domain of this function here? All right, nice, easy question. I thought you were supposed to be the good. You were the chosen one. All right. How do I find this guy's domain? This should be relatively easy.
Anything bigger than -5?
Yeah,
or
the
equal?
inside has to be at least 0, right? So x has got to be at least -5. All right, that's boring shit. That's old boring shit. All right. How do I do the domain of this function? So I'm going to talk about the technical way to do it, and then I'll talk a little bit about, well, a less technical way to do it. Okay. So this is kind of neat because this process we're about to do is used in a lot of different situations, especially maybe in calculus. Maybe. Not exactly for this purpose, but the same process. So where is this 0? So I do want to solve this. I want to solve this greater equal to 0, right? So where is it equal 0? Where are the zeros?
5 and -2.
5 and -2. Now watch what I'm going to do. I'm going to make a chart. Thankfully, put them in the right place. So it's 0 here and it's 0 there. And there was this thing, there was something else I forgot. There's this thing called the intermediate value theorem, which hopefully when you hit that problem, you went back to read about it. That would be great. But it basically says if it's positive on one side and negative on the other side, and it's a polynomial, there must be a 0 in the middle, right? This is kind of related. So does that make sense? If the function is positive at 1 and negative at 3, then there must be a 0 somewhere in the middle. It has to go through the damn thing, right? That's all it says. It's a really dumb thing, to be honest. It's like, well, amazing. It's got to go through to get there. All right. but it's actually really cool. This theorem. Now, what this isn't that theorem, but when I put a 0 in, what do I get? What sign do I get? If I put a 0 in, what sign do I get?
Negative.
Negative. So it's going to be negative for every single input in here. Because where's the only place it could change sign is on either side of a 0. If there's a place it goes through 0, it's let me see if I can. So if it went through 0 there and it goes through 0 there, if it's negative here, how do I say this? If it's negative here, it's negative all the way through this whole region. The only place it might change sign is on the other side of the 0. Stay with me now. What if I put in there a negative 3? I get negative times negative, right? So it's positive. What if I put in there a 6? So I'm investigating the regions. Positive times positive, that's positive. All right, maybe. See how I don't give a shit about the output. I just care about the sign, because this problem is all about a sign. If I relate it to 0, now it's a question about, I want this to be positive. Can you tell me where the answer is now? When is this positive? We see everything. When is this positive or 0? What intervals?
Negative infinity to negative 2.
Yeah, negative infinity to negative 2. I include negative 2 because I allow it to equal, or?
And 5 to infinity.
5 to infinity. All right. Now, here we go. One last question that we head out related to this. All right. So everybody got, let me give you a minute. This is one of my favorite things. I don't know why. I just love this idea. All right. I'm going to erase all this. Here we go. So look at this. All right, you ready? Let's look at this function. All right, I'm excited. What do you got, Jeff? This is so gross. I love it. Oh, sure. We let's not be too evil. Why not? We'll be just a little bit evil. Ew. But still, what's the main idea? The inside of the radical has to be, look how nice I made that, come on, has to be positive or 0. Are you guys with me? It doesn't change. It's still a square root. It needs whatever the shit's on the inside. But, all right. So that's bottom line. Bottom line, it doesn't matter what the hell's in here. It has to be positive or 0 because it's in a square root. Okay. Now, what are the zeros of this? Let me see if everybody's really careful. What are the zeros of this?
Make the top equal to 0.
Yes.
So 5/2.
Yes, so 5/2. What is 4 and negative 4? What are those? Those are where it is
Asymptotes?
undefined. Yeah, well, asymptotes, but it's where these fractions would be undefined. So that's going to be 4, negative 4. Now here's the beautiful thing. Places where it's undefined are places around which it could change sign. So for example, if I had somewhere that I would slam up against, all these values are positive, correct? On the other side of the asymptote, couldn't it do this? What are the values now? They're positive on this side. Right on the other side of this undefined point, they now are negative. They change sign. So it's exactly, this is so beautiful. When you make your number line now, I've got, let's see, negative 4. I've got 5/2, and I've got 4. Notice how I really don't give a shit about scale. That's not the important thing, right? This is not the end of the problem. This is just the middle thing, a tool. Look what I'm going to do. It's 0 here. It's undefined there, and it's undefined there. That way I know that these will not be a part of the answer because they make the thing undefined. Now I could do what we did last time, right? 0 is in here, right? You pick any number from the regions. Now there's one more region that we had last. If you pick any number from the regions, but I want to give you a shortcut. I really want you guys to understand this. So it can only change signs around there. If I throw a 0 in, what's the sign of this? It would be negative over negative times positive. The negatives cancel. It's positive in here. Now get ready. What are the multiplicities of each of these?
1.
The multiplicity is 1. It's odd. So don't they go through? And another way to say that is they change sign. So watch. I know that's negative. I know that's negative. I know that's positive because they change sign around each thing. If any of them had been squared, like if that would have been squared, this would have stayed the same sign around 4 because it would have had a multiplicity 2. That's where it turns. It stays the same sign. That's so freaking cool. So I really just have to do one region and then I look at the multiplicities, bam, bam, bam. If you don't like what I just did, you pick a region and you plug a number in. Positive, 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 positive. Okay. Now, what's the answer?
Negative infinity to 4
No.
or negative to negative 4.
I need the answer to be positive or 0.
Oh.
Can you see where it's positive?
Bigger
Between
than the -4.
Yeah, between -4. See, don't include -4 because that makes it undefined. Up to
5/2.
5/2. And I can include that because it's 0 there. Or,
Bigger than the 4.
yeah, not including 4 up to infinity. That would be the domain of this dude. Wow. Okay. That's pretty good. So I needed to throw something new in because everything else we've done tonight was review. All right. So next time we will actually get into chapter 6. Don't forget about the quiz, right? If you haven't taken it yet, which is basically most of you. So you have until, what did I do? I gave you till tomorrow morning, I think, 9, I think. Can't remember.
Yeah.
Okay. So get in there, do that sucker, and I'll have that graded over the weekend. I'm also hoping to put up in Canvas your current overall average. And we'll see if I got time to. I also like to do if you had turned no homework in or if you had all the homework turned in, what it would be. So you get a little range to work with. Okay. All right. So that's it. Let me know if you need to stick around. Otherwise, you are free to go.
Thanks. See you later.
Anytime. See you guys.
Thank
Have a
you.
good weekend. Is everybody good? Anybody questions?
Yeah, I actually had a quick question.
Yes.
For like the next one on that sheet, number 6, it has x cubed over x squared. So for the
Yeah.
for the horizontal asymptote, do you take the ratio of the coefficients or the exponents on that?
No. So when the top is a higher degree, you have to long divide. That's going to be a slant asymptote example. So I might do that problem first thing next class.
So if the bottom exponent is bigger, then you just take the ratio of the exponents?
No. It's if the degrees are the same, because that means they go lockstep with each other, and that's why it's the ratio. If the bottom power is higher, I'm dividing by bigger, so it goes to 0. So the bottom power is higher, it goes to 0. Y equals 0 is the asymptote. If the degrees are the same, y equals the ratio of the coefficients of the highest degrees. If the top is highest, there is no ceiling, but there will be some kind of a slant asymptote. And yeah, I think tomorrow is the season finale. You're right.
Thank you.
Is that all right, bro?
Yeah.
Okay.
I think so.
It's all on that. There's that one handout that has the 3 situations listed on it. The one that's about rational function graphing. It's got the 3 situations written on it. All right. How's everybody else? You guys good? All right. I'm going to head out. I'll see y'all next week if you're here. All right. Bye.